for now we're just going to talk about periodic data and periodic things in general. A periodic function is a function that repeats a pattern of y values at regular intervals. In other words, there's a cycle, and you'll hear me use the word cyclical. Like sine graphs and cosine graphs are cyclical, so the cycle continues over and over again. That gets repeated every x units. The period of a function is the horizontal length of one cycle. So let's actually get a concrete example of that. So in this first periodic function, which I just showed you sines and cosines, right? It's probably going to be one of those. And I'm going to go to the board for a second. There's a couple of different ways where you could say, here's where the cycle starts and where the cycle ends. If you want to start your cycle right there, then tell me when to stop when I've completed one full cycle. Right there, okay? Now, if I take that, I can pretty much like cut that out, and I can see another version of that there, right? So this cycle started at 0 and ended at 4. That's considered the period of this cycle. It's 4 units long. And if you look at the translation of it, this one started at -4 and ended at 0, which was the same length. So no matter where you then slide each next pattern, it has a length of 4. Now, I started the cycle there. What if you didn't see it that way? What if your cycle, and I'll use a totally different color, started at 1? Tell me then where this would end. There, right? So this one started at 1 and ended at 5. Okay? Still the same period as the previous person, right? It's a period of 4. And if we kind of get a different, slide that over and just let it continue, that would be the next version of it, starting at -3, ending at 1. Still a length of 4. So what you envision as the start of your cycle versus the end of your cycle doesn't really matter. We'll all end up on the same page. We'll all have the same period, and other features that we're about to talk about will be the same. I'll just give you one more example. What if we started a cycle here? And I went like this. Tell me when I would stop. Right? From -2 to +2. Still a length of 4, and then immediately that starting here and going down first and then up would repeat, and this goes on infinitely. Okay? Does that make sense? Okay? So the way your mind sees it, like where your mind chooses to start the cycle, doesn't have to be the same for every person. You know, some of you will naturally gravitate towards one way versus the other. So for the sake of showing it on the notes, I'm going to start my cycle right at 0. I'm going to have it go up, down, down, and up. And then that is the pattern that's going to repeat. Okay? So features we have to talk about. The period is the length of that cycle, which is 4. And then I'm going to start talking about this now. It's always going to apply to sine and cosine functions. It's not necessarily going to apply to a lot of what we do today. Maybe it will. Maybe it will. These cyclical functions have midlines. Okay? They have midlines, which midline suggests what word? What? Mid is short for middle, okay? So the midline is kind of halfway between the very top and the bottom. So if the very top of this is at 2 and the very bottom of this is at -2, where's the midline? 0. So it's a horizontal line that kind of goes through, and I'll make it dotted, through the middle. That's the midline. And we have an amplitude. Has anybody heard the word amplitude in any other context? What does amplitude mean to you? Nate? Okay, sound. Yeah, frequency. That's another buzzword in trig.
Because anytime there's a period, there's a frequency. We will talk about that. And what does sound have in common with what you're looking at, Isaiah? Not necessarily the x-axis, but in this particular case, it would be the x-axis. It's the amount it goes above and below the midline. And the midline is kind of jiving with the x-axis right here. And really, the reason you hear about that with sound, Nate, is because of waves, sound waves, right? And the frequency of them, and the period of them, right? The length of them. Also, colors, right? There's like a wavelength that gets talked about with colors, like high frequency colors and low frequency colors, stuff like that. I'm sure there's applications there, but it's all that. So amplitude is, in this case, to go back to Isaiah because he gave the best definition here, it's the amount that the graph goes above and below the midline, which should be the same number, whether you look at how far above the midline it's going or you look at how far below the midline it's going. It should be the same, right, because the midline's in the middle. And so how far above the midline is this going? 2 units, so the amplitude is 2. Just out of curiosity, what's the max of this graph? What's the max value of this graph? 2, and what's the minimum? -2. And what you'll notice is that the midline is always halfway between those, which is obviously 0 in this case. Okay? So the midline is the, how do I want to define it? The horizontal line that is halfway between the max and the min values. The amplitude I'm going to define exactly the way Isaiah said. It's the amount the graph goes above the midline. Does that make sense to you guys? I want to write a definition that makes sense to you. I have a feeling if I looked up the formal definition, it would be more confusing than just, that's how definitions are. They kind of tend to make it more confusing. And the period is the length of one full cycle. I want to jump down to B on the next section because it's more like a sine and cosine curve. Yeah, go ahead. Okay, so the 3 things we have to figure out are the period, the midline, and the amplitude. Period, midline, amplitude. So, where do you want to start your cycle? Let's just all get on the same page. Give me a point, Jake Hutch, to start my cycle at. B. Give me the coordinates of the point at which you want me to start the cycle. -3, 2 isn't even on the graph. -2, 2. Okay, he wants to start the cycle right there. Great. Okay. So then I'm going to go along here and tell me when my cycle should stop. Correct. So here's my cycle, starting at -2, ending at 2. What is my period, Maggie? Period is the length of that cycle. So from start to finish. How long did that take? 4 units. What is my midline, Kaylee McAdam? You can take a minute to think about it. I'll give you a hint. It's not a whole number. Midline definition, it's the horizontal line that is halfway between the max and the min. So it goes right down the middle of your wave. One half, that would be right here. Does that look good to everybody? How could you calculate it? She's correct. How could you calculate it? Nathan? Okay, but the minimum is -1. The maximum is 2. So if I subtract the minimum from the maximum, 2 minus -1 would have gotten me 3. So that doesn't work. Isaiah? Yeah, but 3 divided by 2 is 1.5. You got all the, I know what you guys are doing, and I know that you guys could get it, but it is kind of a funny thing. So, Nathan, what you said is what Isaiah started to do. That's essentially what he did. He got the difference between the minimum and the maximum, which is what you did for me, right? You did this minus that. So you got 3. You got the difference between the maximum and the minimum. He then cut that in half, which was 1.5. But that's not where the midline is. Kaylee was right. It's at 1/2. What you got, that 1.5, is the midline is going to be 1.5 units above the minimum or 1.5 units below the maximum. Okay? The easy way of calculating would be to just take the average of these. If you want to go halfway between two numbers, just take the average. Right? What Isaiah actually got was the amplitude. So from max to min, it's 3 units tall, which means the distance above the midline is 1.5, and the distance below the midline is also 1.5. So he gave me the amplitude of 1.5. The visual is obviously very helpful here, right? Because when I asked Nathan Henry to give me the calculation, he said subtract one from the other, you would have gotten 3 based on his instruction. If you put a midline at 3, you'd visually see that's not right, you know? Same thing with Isaiah. I know what you were doing, and it's part of the process, but if you then went and put that midline at 1.5, you would know that doesn't look right, okay? So you can average, if you want, the max and the min, or you can just sketch it out and look at it. Okay? The amplitude comes from the maximum minus the minimum divided in half. That's that difference of 3 divided in half. Okay? The amplitude is always positive, by the way. I don't know if you remember that from science, but the amplitude is always positive. Okay? All right, in this example here, I just want to talk about it. Is it periodic? And the answer is no, right? Because it's not fluctuating back and forth between the same max and same min. There's a pattern there. I don't disagree with that. But it is not periodic because there is no max and min that it keeps oscillating back and forth between. Yes. No. We wouldn't even talk about max, min, because there's an arrow on the end, and it's going to keep going forever and ever. And periodic functions do have arrows on the end of them. They extend infinitely, but they have to have a max and a min, and just, keep going back and forth, back and forth, back and forth. This one would be periodic. It's obviously not what a sine and cosine curve look like, but there is a max, there is a min, there is a repetitive pattern, and so forth. We're not going to do that one just for the sake of time. Okay? This idea of frequency, here it is. If the period of a function is 4 seconds, okay, that's the period, that's the length of one cycle. Frequency is this idea of how many cycles then can we fit in a certain amount of time, okay? So if you knew that the period was 4 seconds, and I'm just going to do, a 4-second sketch, how many of those am I going to fit in by the time I get to 60 seconds? Kaylee? 15. And how did you do it? Right. 60 divided into 4-second intervals, because every time a 4-second interval passes, that's one cycle, gives you 15 cycles, and that is your frequency. It's the number of cycles that fit in a set amount of time. Now let's think backwards. Something is completing 180 cycles in 1 minute. There's my 1 minute. It's going to do 180 of these, right? So how long did just one of them take? What do you think? 1/3 of a second. Correct. So what's our formula? So how did you get that? Frequency, you did the 180, right? The number of cycles. Oh no, that was our frequency. To get the period, you took our number of cycles. No, you didn't. You did 60 over 180, right? You did the 60 seconds divided into 180 parts, right? Right, right. But what you truly did is you took the amount of time and you divided that into 180 cycles. Yes? And that gave you 1/3 seconds. So the period is the length of time over frequency. Here, to be truthful, this is 180 cycles per second. Right? Oh no. Per minute. I don't really care about the units. I have to think more about that before I misinstruct you. There's something there where the units will cancel out, but let me think more about that, and I'll show you later. Maybe Friday. Because there's a way of, I got to think more clearly about how I want to say it so I don't confuse anybody. So here's where I kind of give you a formula for the amplitude. To be honest with you, I don't memorize that formula. I'm not going to make you memorize that formula because I think with a visual, you can kind of figure out the amplitude on your own, like how far above the x-axis. And again, I'm going to constantly encourage you to sketch pictures of these curves and make sure your amplitude answers are making sense. Like for example, on this one, if this is my minimum at -2, and here's my maximum at 1, how many units apart are those? 3. So my midline is going to be 1.5 from the bottom and 1.5 from the top, yes? So if I go down 1.5, that puts me right there. I really truly do prefer to think about it logically versus memorizing a formula. I'm only a believer in formulas if they're so advanced that logical thought doesn't work. So there's my midline, and therefore my amplitude is how far above did we go? 1.5, right? And how far below did we go? 1.5. This one's funny. Looks very different. Here's our, I'm going to use that as the start of my cycle. So the end of my cycle is right here, isn't it? See that? So from -2 to 4, what's my period? 6. My max is at 3, my min is at 0. So where's my midline? What's halfway between 0 and 3? 1.5, right? So we get it. Jump down to 5. Sound waves. Sound is produced by periodic changes in air pressure called sound waves. The yellow graph and the digital, I think that's the top one. It's supposed to be yellow. Shows the graph of a pure tone from a tuning fork. What are the period and amplitude of the sound wave? So this has a minimum at 1.5 and a maximum, it looks like, at 2.5. So where's the midline? 2. If the midline's at 2, what's the amplitude? What is it? Isaiah? Andrew? The amplitude is not 1. My midline is at 2. My max is at 2.5, which is 0.5 units above, and my minimum is 0.5 units below. So the amplitude is 0.5. Okay? And my period starts at 0 if I go with that cycle, ends at, what's that? 0.006, right? 0.006 seconds. So you make sure you're paying attention to your scales, how the x and y axis are scaled. And then the last one here with us sketching our own graph. So sketch a periodic graph with a period of 0.02 and an amplitude of 4. So guess what? I'm gonna call this 0.02 just to really spread it out, and that's gonna be 0.01. And I'll just go an amplitude of 4. So I'm going to let this be my midline. I'm going to go up 4 and back down 4. And then below by 4. And back up. And then I would continue that pattern. So I'll just put an arrow on both ends as if it goes on infinitely, but I just gave you one cycle of it. Does that make sense? Okay, so just kind of takes a little more thought. Just a couple things I